Retooling in Industry, Interdisciplinary Design, Igniting Economic Development. This webinar is brought to you by the Open Architecture Collaborative, the American Institute of Architects Housing Knowledge Community, and EDI International, which provides technical support. I'm Steve Schreiber from Amherst, Mass., and I'm the moderator of today's webinar. The presenter is Dr. Gregory Lujan, AIA. Greg is the Associate Dean for Administration in the College of Design at the University of Kentucky, and he's the Kentucky Housing Corporation Professor in Affordable Housing Design in the School of Architecture. His expertise includes digital visualization leading to digital manufacturing with the application towards design build projects, full-scale assembly, and incorporation of ecological design. The learning objectives of today's webinar are: 1, understand and describe how a university design build program can address community welfare, including significant urban challenges like economic development, social justice, the regeneration of urban communities, and the effect on economic, environmental, and social change. Greg will discuss how integrating housing into a broader sustainable vision taps and leverages community resources, including affordability, quality of life, and public health for residents. He'll describe how the design and development addresses environmental objectives. And through this webinar, you will learn the value of engaging in collaborative, interdisciplinary, public-private partnerships in the planning, design, and development of innovative housing. The course description is described below. I'll just read you the first and last paragraph, but feel free to read along. The Houseboat to Energy Efficient Residences program taps into the experience of the houseboat building industry in southern Kentucky in the Lake Cumberland area. That industry has fallen off, leaving skilled workers and facilities available for the projects that Greg will be describing. As a collaborative enterprise, the Houseboat to Energy Efficient Residence program has created 157 jobs and provided over $5 million in economic impact in Eastern Kentucky. The way that this works is Greg will speak for approximately the next 45 minutes. We encourage questions, so the questions should be entered into the chat box that you should see on your screen. At the end of Greg's presentation, I will read the questions in the order that I've received them and try to bundle them so that the questions that are related will be asked as one. And Greg will try to answer those during the question and answer session at the end. We will end exactly at the hour, so hopefully we'll be able to get through all the questions. But if not, Greg will have the opportunity to answer those questions, and we'll send them to those who have registered for today's webinar. This presentation is protected by the U.S. and international copyright laws. Reproduction, distribution, display, and the use of this presentation without written permission of the speaker is prohibited. This is the required compliance statement of the AIA, so please read this. Questions related to specific materials, methods, and services will be addressed at the conclusion of this presentation.
Thank you for the introduction, Stephen, and thank you all for attending. This presentation will present 3 interconnected case study projects that fall under the umbrella of Design plus Energy Initiatives, or DEI-based projects. This built research will include a discussion about the LEED Silver Certified Residence House, the first LEED certified house in the state of Kentucky, the University of Kentucky's award-winning Sky Blue Solar House for the 2009 Solar Decathlon, and culminate with the Houseboats to Energy Efficient Residences affordable prototypes for Monticello, Emlyn, and West Liberty, Kentucky. My primary responsibilities at the University of Kentucky, including teaching digital design studios and seminars on design and computational theory, systems thinking, and design computing. My teaching methods are rooted in engagement-based research and continues to examine the link between academic training and professional practice. I often use the specific approach and method of discovery to bear upon my educational lesson plans in the design studio, where students envision architectural projects in detail, whether at partial or full scale. Whether at partial or full scale, these projects have been recognized with awards and exhibited at international venues and exist as formative opportunities for future collaboration, speculation, and documentation. Students today need to be savvy of the modern economy. They need to be able to think differently and creatively, and most importantly, think across disciplines. Critical thinking skills such as design thinking and systems thinking enable our students and architects to not only generate solutions, but they also provide them with the ability to see the problem simultaneously from multiple vantage points. This way, design problems can be reconceptualized. Akin to the academy, faculty and students must be adaptable, collaborative, and technologically skilled. They must be sensitive to designing for humans and environmental needs. And in order to do so, what I've been advocating for in the projects that you'll see today is to match assets to opportunities through big picture thinking. Why? Because big picture thinking enables a concept that is both timeless and current. I want to emphasize that one of the keys to interdisciplinary success is making ideas scalable. Projects do not always have to result in a building. Rather, I have found what is to be most synergistic is testing and calibrating valuable proof of concepts or points of discovery. At our college, there are typically two ways that faculty pursue funded research. Each start with a faculty aligning their passions with opportunities. In the trajectory that's listed above, the first trajectory, faculty identify an interest, they align it with a community need, explore it in the design studio, exhibit the results, and then fundraise for the project so that it can be implemented. Upon completion, they celebrate their ideas through implementation. The second trajectory that's shown at the bottom is more aligned with what today's discussion will be about. It is an integrated approach that resonates between ideas, community needs, and financial support, whether funded by grants or through other fundraising sources, that enable an integrated feedback loop. This feedback loop then generates outcomes and next projects, loosely called from installation to habitation. What we've been able to recognize is a seamless transition that also creates and leverages creative links between the academy and industry professionals. The University of Kentucky is a land-grant institution, and as a full professor of architecture and historic preservation, I'm a strong advocate for paving roads that would facilitate a clear vision for advancement in all three dimensions of the university's land-grant mission: learning, discovery, and engagement. In my 19 years of service at the University of Kentucky, I've engaged in a focused research that has mined the Kentucky context. The context that I'm referring is both internal and external to the college. Context includes the places of collegial interactions among faculty, staff, students, and community. Context also relates to the pedagogy that is necessary for accreditation and licensure. Context also refers to the taking on real-world problems and challenges in the community and working to solve them in creative ways. I would also like to advocate strongly for the college and the department to be actively involved in planning the campus and the regional urban communities that surround the college. For me, in Kentucky, what started as an organized bus tour through the Commonwealth has transformed into a research and engagement instrument that has helped me to provide opportunities where design and architecture could play a role in improving the lives of the community. Design today is positioned not only in the context of professional practice, but also in the realm of politics, business, sustainability, urban planning, and integrated landscape. This common thread is the context of my research. I was keenly advised by the university president that if I can solve a Kentucky problem, that chances are I could solve a global problem. As such, I developed a personal tagline and brought this tagline directly into the classroom. The subtitle of this presentation could easily be labeled Beyond Building, because it is for this project, the residence house, that we actually went to the forest to sustainably harvest trees, from which we use portable milling machines to take and make our own siding and flooring. An opportunity that presented itself is the Lead for Homes pilot program. Our integrated studio included architects, interior designers, preservationists, engineers, and urban planners. We had to present our project in front of a televised historic review board. Typically, when projects are presented, 2D images are shown on screens, and the board of this review reviews and suggests comments for approval prior to approval. The board usually sits above the presenter and often views the presentation from a distance. In our case, we also presented a 6-foot by 12-foot site model that captured the entire context in 3 dimensions. It was the first time that the board engaged the crowd. Similarly, we wanted to push boundaries in terms of the fabrication and assembly of the project. We worked diligently to incorporate a whole range of aspects that would enable a modular construction. We worked directly with Bill Zahner at the A. Zahner Company in Kansas City, Missouri, to fabricate the light vortex structural element of the project. We also wanted to engage methods of analyzing integrated project delivery with prefabricated modular construction. We realized that not only would we be saving time in this project, but we would also enable an art-to-part facilitation for the construction. We were also able to utilize the underutilized research by reaching out to the University of Kentucky Department of Forestry and its Wood Utilization Center, which was built in the 1960s to teach people how to grow trees and to turn them into products. Our sustainable concepts resulted in using scraps of flooring fabrication as solid butcher block freestanding staircases. The residence house was certified LEED Silver in August of 2008. It was also the first LEED certified house in the state of Kentucky. The studio separated into 3 distinct yet intertwined components: detail and design, fabrication and assembly, and documentation. Like other design build projects that are hosted at other universities across the state, we started a not-for-profit company that enabled design build projects for the University of Kentucky College of Design. Our first project was entitled The Residence House. This project is 4,400 square feet and costs $3 a day or $90 a month for gas, water, and electric. It was the first LEED certified house in the state of Kentucky, certifying at silver in 2008. The reason for it certifying at silver instead of platinum was less about performance and more about the scale of the project. We needed the project to fit into the historic context, so building something smaller, like 1,200 square feet, as you'll see shortly, was not appropriate for that particular context. One of the challenges that we have in our school is, of course, thinking differently. Like many programs, the University of Kentucky College of Design School of Architecture uses a project-based problem to examine topics and to test them. In my teaching, I often challenge my students to jump scale and implement them. It is within this context that students are afforded an opportunity to work on both theoretical projects and built projects from initial concept to construction administration. In turn, my students rapidly develop a solid theoretical grounding through thought and representation that links sustainable architecture and design and structural analysis to fabrication. And this serves as a way of generating a voice that is simultaneously up-to-date and timeless. For instance, every component of the Sky Blue Solar House was fabricated and was part of a research project. The tagline that I described earlier, "By Kentucky for the World," became the mantra for this particular project. Many of the calibrations that were used for this research were supported by additional funding sources and the R&D investment that totaled $1.25 million. But clearly, all $1.25 million did not go specifically for this project, but for the research and the components of the research that were integrated into the project. This ranged from rainwater harvesting systems to irrigation systems to solar thermal and photovoltaic systems. As you may realize, that working on projects such as the Residence House or the Solar Decathlon provides immediate impact. For instance, with the Solar Decathlon project, it generated 36 million media impressions just during the event itself. Projects such as these are also a viable project for schools like the University of Kentucky, who have access to comprehensive programs across the university. These programs could then be coupled and create internal synergies, such as university extension, construction science, landscape architecture, real estate development, and visualization. Since the University of Kentucky did not have a comprehensive college internally, it seemed natural to move beyond the college to include not only design, but engineering, communications, and agriculture. After the Solar Decathlon, the House toured the Commonwealth and was part of the Visitor Center for the 2010 World Equestrian Games. It is now set on campus. We had 175 students from 4 different colleges and 16 different centers involved in this project. The project gave us an opportunity to reinterpret the Kentucky vernacular house and align it with an affordable solution. This project continues to be used as a research and demonstration facility on the University of Kentucky campus. These 2 projects have led to the HBR Project, houseboats to energy efficient residences. On the heels of the Solar Decathlon, which enabled 175 freshly educated minds, we formed strategic alliances with university partners that challenge not only how we define the box, but how we look at the box in creative and innovative ways. We have been building housing prototypes for the last 7 years. The 4 goals of the project are to train and employ Kentuckians, to restart an idle houseboat industry, and to restore it to capacity pre-2008 economic decline, to construct low-cost, energy-efficient projects, and ultimately to incorporate 90% of the building materials from Kentucky manufacturers. Since 2013, we have received $1.1 million in grant funding to develop the next generation of houseboats units and to expand the portfolio beyond housing. This project will conclude in December of 2016, and upon completion, it will be the largest solar village east of the Mississippi River. The initial value to the college relied on new ways of thinking about the decimated houseboat industry. How do we put these workers back to work if there is no demand for houseboats? Since we launched the HBR project, we have generated over $5 million of economic impact, $1.75 million of funded studio support, and most recently, the $1.1 million TVA grant that demonstrates the clear value of design. HBR first started as a war on energy inefficient trailers, but has grown to include the prototypes of classrooms, offices, clinics, houses, and restaurants. This project includes homes that meet or exceed the USGBC Lead for Home standards, engage both single-family and multi-family dwellings, and has been built to maximize time savings by integrating parallel processes both in the site and in the factory. The award-winning projects have been exhibited nationally and have been trademarked. HBR has not only generated $5 million of economic impact for the community, but it has also built the college's capacity to respond to weather-related storms and tragedies such as the tornadoes and floods in the region. Rather than looking solely at how do we solve the condition of housing, HBR is now a systems-based approach that addresses community needs. It has improved resiliency in the community, and it has generated a stronger context of how the college operates around its environment. The context that I'm referring to is both internal and external to the college. Context includes the places of collegial interactions among faculty, staff, students, and community. Context also relates to pedagogy that is necessary for accreditation and licensure. Context also refers to taking on real-world problems and challenges in community and working to solve them in creative manners. I advocate strongly for the college to be actively involved in the planning of our campus, the university, and the regional planning around the campus, but also in terms of its collaboration and its opportunity. I see this as an opportunity for it to be ripe with collaboration. In this sense, collaboration is not only amongst peers within the institution, but also between the professional community and the academy. Institutions of higher education in the region and internationally, collaboration is an underlying framework and foundation of our own research. The foundation is rooted in team science, team building, and teamwork that advances the entire college and the community that surrounds it. We work as individual team members, but also as a collective entity. Central to this theme is our own initiatives to think in horizontals that connect people across disciplines that not only make the university stronger, but also address community needs. This context and the collaborations that I would like to refer to as calibrations. I'm an advocate of not a one-size-fits-all, but rather an advocate for synergistic and opportunistic nimbleness that takes advantage of the resources that we have at our fingertips, the facilities that surround us, and the yet-to-be-known needs that will undoubtedly require as we move forward. The images that you see on your screen were the initial prototypes for the houseboats to energy-efficient residences that built off the vernacular in Kentucky. As you can see in the photographs, here are the images that are being produced in Emlyn, Kentucky now through the HBR Project. The houses are 1,300 square feet. They range in HERS ratings between 10 to 15. They are very high performance buildings that are also very energy efficient. They're being constructed for between $75,000 and $90,000 and being sold. As mentioned earlier, when this project is completed, it will be the largest solar village east of the Mississippi. As mentioned earlier, these projects have expanded the palette of projects that move beyond housing and now includes offices, restaurants, schools, and clinics. As part of this approach, it has been necessary to create meaningful exchanges between the area community and the program. This is what I would say of vital importance. As a professor, architect, and scholar, I am constantly looking for avenues to create synergies that are larger than a one-off project. My applied research within the academy and the research that goes on in our college takes the form of applied service learning that literally transforms the classroom into a three-dimensional textbook. By evoking integrated design within the collaborative context, such as the residence house, the sky blue solar house, and the HBR houseboats to energy efficient residences, enabled these types of projects to emerge. This approach has not only enabled a critical opportunity for advancement within the architectural profession, but has also ultimately widened the knowledge base of our built environment while forging critical relationships with disciplines outside of architecture, most notably engineering, education, business, communication, and the fine arts. I firmly believe that the reason why clients hire architects is that we have the ability to think comprehensively and to act critically. I am a strong and vocal advocate for expanding the role of design as an agent of positive change in society and also an advocate for sustainable practices. The goals of these projects that have been presented today is also to promote change in the way that we build, change in the way that we live, and change in the way that we impact our environment. I would contend that within the academy, we should also develop an untapped potential of our students' mind to inspire creative thinking using both historical precedents and the digital tools of today. This will enable the effective positioning of our graduates for jobs in 20 years that will either be radically different than they are today or to work in industries that might even exist today. Thank you very much for your time, and I'm open to questions.
So we are at the point of questions, and I apologize. I was actually cut off from the phone call and busy trying to get back on. So let me just look through what's here. So Greg, really one of my questions is, what's next? Where do you see this, or how would you see people in other communities possibly using the lessons that you've learned?
Well, thank you for the question, Stephen. The HBR project and all the projects that we've been working on definitely start with mining the local context. All of our designs are based to have impact by understanding community needs and then translating them not only into formative research that could improve the lives of Kentuckians, but this is something that could easily be transferred across many different universities and states. There are several examples, of course, the Yale Building Studio, University of Texas, University of Kansas Studio 804, the Rural Studio. These are examples that take a project well beyond the one-off and design them into a capacity that continue to engage their communities and then positively impact the people that are around them. I think the biggest opportunity for HBR is that we're as limited as our own ideas and our imaginations, and that could easily be scaled to other types of projects. There are several other projects that are part of the HBR that also include, for instance, the end of cure time. When hospice comes into effect, we have design modules that can plug into hospice, that plug into conditions of existing housing, and have also scaled those down to games and puzzles that are used for people that have other cognitive disabilities. So it's essentially taking the projects at a variety of scales and really retooling the industry in a way that transforms not only the communities that they serve, but the people that construct them.
That's great. And in the time that this project has been going, are you aware of any projects that have been inspired by yours that have moved forward in other areas? Like
in other contexts?
Yeah. The ones that have been directly that you've been a consultant to?
We've been consultants to lots of projects that have happened around our state. I'm not aware of any that have gone on. We've presented these at national and international conferences. We've extended that, working with the LEED for Homes. We've done several of the LEED houses in the state of Kentucky have been generated by the university. We presented these houses. These are also based upon models of Studio 804 and the Rural Studio in our own college, where we've started a not-for-profit that enabled the types of building capacity that Studio 804 has done. The one challenge that we have is that we're not actively engaged by being in the community, say the way that Rural Studio is in Hale County, for instance, Alabama. We are centered in Lexington, Kentucky, but we serve the entire state. And most of our productivity has been in the eastern Kentucky region in what's been called the Promise Zone for the community. And it's a way of extending the building capacity of that area. For instance, the houseboats to energy efficient residences is a multi-year initiative that not only seeks out design and energy efficient homes in the houseboat industry, but the intent was actually to retool the entire houseboat manufacturing in a way to align them with digital technology. So part of that economic downturn that happened in the 2008, right around the time of the Solar Decathlon, has now been repurposed and now is addressing energy efficient housing and also creating new jobs in the area. So this is definitely something that could be extended well beyond our region.
What are some lessons learned that you could give to professional practitioners outside of the academic world? So outside of working in a university, say someone who really is primarily in private practice, what are some advice you could give?
Well, the work that we've been doing here at the college has focused specifically on entrepreneurial aspects, aligning our design ideas to tapping into community needs and recognizing those needs. This idea of working in a systems way or a systems thinking approach enables us to see the problem from multiple vantage points. And often we realize that when we're working in design projects, that the architect, even though we're broad thinkers, might not have all the answers. So it's enabled us to really tap into a wider range of expertise. That includes the engineers as well as business side. But we also realize that if we can make the best widget in the world, but if we don't communicate our ideas effectively to the largest possible audience, that we're missing out. So we've learned from partnering with community and communication activists here on campus to actually help to broadcast our message. So one of the biggest advocacies that I would have for the profession is to not only believe in your ideas, but to, as you start to implement them and surround yourself with a very formative team, is to effectively market and communicate your ideas to the broadest ranging audience, and to use colloquial terms, not jargon-specific terms, and this would help the community understand better what you're trying to accomplish. Now, often when we have been working with these communities, we go in with amazing ideas and strategies in order to solve a range of problems. Often, though, what we find is that they either have not thought about these problems in the same way, or they're not necessarily seeing them as problems to begin with. And so often we'll go into these communities to solve the housing project or a process of fabrication that would help to build their own capacity. The challenge has been is translating those opportunities into really formative opportunities that they value, that the community values. So definitely the ability to communicate your ideas has helped with that valuation process. We've also been doing a large number of design charrettes where the community has been actively involved, also working with school children in elementary schools, reaching as far back in the design pipeline as we possibly can, so that by the time that students get into the high school, that they're very aware of the capacity of the college. So this would be something that could easily be done by linking the profession to grade schools and other institutions.
Awesome. What about metrics? This is a question about, do you establish any metrics from the success or desired outcomes? So before you start the project, what you want to accomplish, and then do you measure them, at the end?
Sure. We actually have three different types of assessments. One are internal to the project themselves, aligning the research goals. We could take the example of this sky blue solar house, for instance, where every aspect of that project, the image that looked like a motorcycle engine being pulled apart with the points of reference to them, each one of those numbers represented a student or a team of students that was working on an integrated research project. So in those particular cases, we had the research, the deliberation, the prototyping, and then the outcome. The second aspect that we have of the assessment is the data. The data we continue to receive from the solar house has helped us to generate next generations of projects and to also improve the HBR units. We've also included technology in the HBR units where the spaces are constantly being monitored to teach people how to build better buildings, but also the inhabitants, the owners of these houses, to teach them how to live, and to learn from how they live in order to calibrate the house so the house starts to become increasingly more smart. And then, of course, there's the internal assessment for the studio themselves and student learning. We realized very quickly that if we can give students real-world opportunities where they can build their ideas, that they would have a larger internal investment to that. That has also increased the self-efficacy of the students and their ability to have greater confidence to not only address, say, NAB criteria for studios, but also their own ability to transfer that knowledge to things that they have that they are passionate about, or that they want to be able to express their passions. So not only are we collecting data about the self-efficacy of the students, we're also internally collecting data about the projects themselves, their performance, and then how we're transforming them into learning lessons for not only the students, but also for the community. And we've been then taking this assessment on the road to work with the local houseboat house building industry to talk to them about the advantages of high performance, because as we know that if our goal is to achieve a net zero building, we can achieve that with the largest solar array possible and not have any impact on how we live. But if we design the house or a building appropriately and to have it to be high performance, that not only will the building perform better, but the amount of solar integration or renewables that would need to be needed for the building would actually be greatly reduced. So it's about right-sizing the designs based upon the information that we've been gathering along the way. And we've been gathering this data now since 2006.
Perfect. Here's a question. Have you taken your model to the traditional mobile home industry?
That's really the next step for our project. Clearly with the HBR, we've been looking at how do we put people back to work. So our focus has been building our own internal capacities for job creation. If we had to prioritize what our ideas were for the HBR project, it has been focused specifically on how to generate the highest energy performance building possible and make it affordable to the community, and then to replace inefficient structures with more energy efficient structures, and then increase the tax base of the community by now having them be firmly rooted into the community. A lot of our research when we were focusing on the Solar Decathlon project really focused on this idea of mobility and increasing mobility. So we have research that's going on in our college right now that focuses on that idea of the frame and transportation and the ways that the modules can actually aggregate in the most efficient way. We haven't brought that out to the industry yet, mostly because of our trademarks that we've been working on in our own college. You saw the code, the College of Design Energy. So that's the code for our project, or the acronym for our project, and that's been focusing on a whole range of types of construction, not only on the mobile industry. But we really see that the next step of this is on a more entrepreneurial side to leverage this to the next step. And so larger scale constructions would focus on that, or larger mass production. We're hoping that the houseboat industry, we've already started because of this project. Wayne Modular Structures is a company that's generated out of the houseboat industry. So while the houseboat industry was totally decimated following the 2008 economic decline, we've started to not only increase the number of jobs, but there's been offshoots of our project that are starting to positively influence the communities in Eastern Kentucky. And so we're hoping by changing the prototypes that we can actually have a lot more impact in the communities. So now that's why we're expanding the portfolio well beyond residences to include multifamily, schools, houses, clinics, and restaurants.
Awesome. Here's a question. Have the subject systems been evaluated with respect to their applicability to attached and or multi-level multifamily housing and other buildings?
I'm imagining is that just focused on renewables, or is that focused on the systems integration itself?
I would imagine that, let's see, it's the, I'm sorry, you asked your question back? Correct?
Well, I'm wondering if the integration, we are constantly studying the scalability of all of our solutions. One of the advocacies that we have in our project is something that's been advocated in a lot of recent literature about the 6 S's, and understanding how the site, the structure, the skin, the systems, the spaces, and the stuff that we put into houses have different life cycles to them, where the sites have been around for billions of years. Structure, when we visit the Roman ruins, we're actually looking at the remnants or the structural elements that remain. We're also looking at the performative relationships of skins, and the skins last maybe 50 to 100 years, where the structure lasts thousands of years. The systems, though, do fail within 15 to 20 years, ideally, not shorter than that. But we always have to be cognizant of the fact that when we have to remove the systems or the electrical, mechanical, plumbing systems from a building, how can we facilitate the transition without without loss? And one thing I forgot to say about the residence house is that even though the house was 4,400 square feet, and a house of that size would generate between 18 and 20 tons of construction waste, we were only generated 3 tons of construction waste. So that was another way of assessing what we were trying to do with that project. And so we measured everything as it was coming into and off of the site. And a lot of that process was just done through the efficiencies of digital fabrication and design. And the way that we've leveraged that now with these modular constructions is starting to separate out the structure from the systems. So if they ever did need to be replaced, it would actually be more plug and play than destruction and then debris going to the landfill. So this was another opportunity of making these ideas scalable. So we're looking at these kind of transitions from these small art to part projects that could be construed as a one-off, but are actually building their own capacity because they're constantly being investigated and researched and then brought to the next scale.
Thank you. Another question has come in. How can digital manufacturing, such as 3D printing, et cetera, be scaled up to provide jobs in a new economy in poor communities?
In poor communities, and specific in poor communities?
Or in, pardon me?
Well, I think one aspect of the digital revolution as we're talking about it, and we already see prototypes being done in other communities internationally, where you have the ability to actually 3D print concrete or other types of forms. I know that there's a tremendous amount of research that's going on at MIT right now, and with some industry partnerships with fabricators that are looking at printing a whole range of materials from soft rubber materials that are pliable to hard, more rigid materials that could actually be printed like concretes. And so if you have the ability to test out all those materials, knowing that there's different types of nuances and adaptabilities that need to be embedded into wall systems, for instance, or even into flooring or roofing systems that are resiliently based, you will have the ability, if you have the right armatures and apertures and materials and facilities and access to resources to actually, the community could actually 3D print their entire environment. So I would say that there is a future potential for that. I'm not sure if we're 100% there at this time, but that's definitely something that's coming down the pipeline, especially with the maker movement and the scales of individual objects or art-based objects that we can make today, including 3D printing food. So there is an ability to control that right at the beginning. The challenge, of course, would be designing them, and a lot of my research is in flexible form manufacturing that really is being driven by the processes of construction, but then aligned to context. So in those particular cases, we want to make sure that we're not just making a generic project, that we're actually making something that the individual values and the community values. So if we can align design processes with manufactured solutions, I think that's really going to be the future.
Thank you. Another question has come in. The solar village designs look to have minimal and small windows. Can your performance standards be met with more and larger windows?
They can be, and we're demonstrating that with the solar house and also with the residence house in downtown Lexington. The rationale for the window to wall ratios has really been the size of the windows are 3 feet by 5 feet per aperture. Some of the windows are a little bit smaller than that when we get into the bathroom areas, for instance. But 100% of the building has access to natural light through the windows. We did look at the performative quality of the windows, and one of the challenges that we had was making high performance windows that gave us the resistance values of the wall, which was very difficult to do without spending a lot of money on the actual glazing systems themselves. So there was a balance for these projects between energy performance and cost. Again, what we're really looking at is a house that's being constructed between $50 to $75 a square foot, and window systems that have triple insulated or quad insulated panes that are higher performing or have aerogels or other proprietary materials in them are very expensive and cost prohibitive for the amount of window-to-wall ratio that we're looking to achieve in these projects. We definitely have done that, though, for the Sky Blue house as well as the Residence house, where the larger window-to-wall ratios have been opened up because of the thickness and the capacity of the wall and also the performance. Both of those were really prototypical homes that we then scaled down to fit the affordable market in Kentucky. But yeah, that was definitely something that we were looking at very specifically is how do we make the windows and the spaces feel a lot larger than they are and connect them to the natural landscape. You saw in the backgrounds of the images in Emlyn, it's a quite amazing scenery that's immediately behind you. So we do have porches that open up to those vistas. And the idea is not to be isolated and be in a windowless environment, but rather one that connects you to the context.
So for those who, because we might have some academics there on the line, how many faculty were, specifically architecture faculty, and what percentage of your students have been involved in your work? So I guess put another way, would pretty much every student that's gone through the University of Kentucky been exposed to your work during their time studying architecture?
Well, the idea of building things at full scale is well beyond just my own capacity. This is something that I've been integrated into all of my teaching since I came here 19 years ago. But definitely there's been a tremendous amount of students who have gone through our program. For instance, with the residence house, there was only we basically started designing that project in 2004. We completed it in 2006. So in that time, the students were very much invested in trying to see the idea go from ideas to implementation. And so we had a significant number of those students stay on the entire 4 semesters in order to complete that work. But they also then transitioned from being undergraduate students to graduate students as well. So there was an opportunity for them to extend their education by realizing the building. So with the Solar Decathlon, or with the residence house, we had 75 students that were involved in that project, and it was really done under my leadership. But we would bring wall sections to many of the firms in town. We worked with a structural engineering company in town as well that helped to realize the potential of these projects. They had students in engineering that were working with us as well, both from the electrical, mechanical, and structural sides, and also from their construction science department. So, it was definitely a lot larger than just architecture only and architecture faculty driven. With the solar house, we had 175 students that worked on that project, and we basically had 3 faculty, one from design, one from engineering, and one from communications that were in charge of the entire project and the rationale for making the entire project happen on a day-to-day basis. But there was basically 2 of us faculty that were leading the charge from engineering and design side that were in the field constructing with the students on a daily basis. Every chance that there was a learning opportunity to turn the classroom literally into this 3-dimensional textbook, we basically took on and really enabled it in a very aggressive way. As one of my colleagues in engineering said, that he had more learning opportunities with that project than he did in an entire career of working at the university. And mostly that was literally every aspect of that project was a research aspect. So we had several other faculty that were leading those research interests of the students that were then plugging them into the building. So it's very difficult to capture how many faculty and students were actually captured in that one. Now with the HBR project, over the 7 years of building with these projects and having 50 to 60 students a year building on this project, we've easily had over 400 students involved in it, not only in the design studios, but also on the research side. Because of all the research funding that we received for those projects, we're definitely a lot more engaged. We had Beyond Me, which is working mostly on the transition from Solar Decathlon to the HBR. projects and now into the research phases of the HBR project. There were several other faculty. I think there was a total of 7 faculty, plus visiting professors that came in as part of the John Russell Groves Endowed Professor of Affordable Housing. Joe Tanny from Res 4 in New York spent several semesters in Kentucky working with us on these projects. And of course, they've gone on to a lot more success with their dwell homes. And David Biaggi, Bruce Swetnam, Mike Jacobs, Gary Rawbacker on the initial phases of HBR. They've been continuously involved in the project throughout their entire life of the HBR project. And David, of course, has gone on to take these projects on to different initiatives with these scaling puzzles and end-of-life units. So they have a lot larger than just the unit themselves, the final project themselves. It's really taken on a whole life of its own.
Wow, that's wonderful. Believe it or not, we have time for one more question. So
okay.
What was the most surprising thing that happened during the project, and how important, actually it's 2 questions, and how important was being open to ambiguity, just letting the program unfold, how important was that?
Well, I'll start with the second part of the question first, because I can honestly say that if we would have thought that we would have ended up where we are right now at the beginning of the project, we never would have achieved it. It's been amazing how this project has taken on a growth of its own, a life of its own, aligned it with not only faculty passions but student passions, and very actively engaged in the community to not only change the way that we teach, but improve the way that we teach, but also change the way that people live. This has been a really amazing journey, especially over the last 10 years, so the last decade of working, especially taking these ideas that would typically be done at, say, installation scale or at the object or theoretical scale, and watch them transform and blossom into ones that are community engaged, not only at full scale, but just the scale of the community involvement has been priceless. Originally the intent of these design build projects was just to show the value of design in the community. But what we quickly learned is that by transitioning from a more theoretical construction phase in the studio into a real world solution, that the community needed to be engaged, they needed to value it, they needed to be able to implement it, because ultimately we needed to have their buy-in into the project in order to make it even more broad than it was expected to be. So if we just compare the change in industry partnerships from the residence house, where we were bringing wall sections and details to different firms and working with manufacturers to not only teach the students how to build better buildings, but also learn from the processes that changed the way that industry people were working on their projects. That became leveraged now to working with a group of angel investors with Kentucky Highlands Investment Corporation that has really transformed the way that the general public perceives not only the value of design, but by including it into jobs creation, has radically changed the value of what we do as architects, designers, thinkers, and academics in ways that were not even possible before. And so I think that the more organic approach to it is to work with the collaborative team that you have to not only address the community needs, but to set the system's boundaries in a way that could be as formative as possible. Of course, we didn't talk about it today, but a lot of the research that went into this was funded by the National Science Foundation and allied faculty members in engineering, education, business, and marketing, as well as design, that collaborated together on a systems thinking for sustainability grant. And that allowed us the tools to develop a systems approach to the design that has now been fully implemented into the HBR project. So not only are we building our own capacity for the houseboat industry, but just the way that we've been working with the communities and being a lot more responsive in terms of the college working with the communities in general. It's been, again, this is what I would call an applied research within the academy that takes the form of applied service learning that literally transforms the classroom into a three-dimensional textbook. So that part we already knew, but the amount of life and the amount of legs and how it's been really informing what the students are doing in the classroom well beyond what I'm doing in my own class, transformative. So that's been probably the most synergistic aspect of the entire project. And hopefully I addressed the first part of your question as well.
No, that was perfect. That's great. So let's see, I think we have a couple more, well, first of all, thank you so much, Greg. And we have a couple more closing slides here for those who are on the webinar. So this concludes the AIA CES course. You'll get a webinar survey report in your follow-up email within the next hour, but then that is also listed in the chat box. So we'll report credit for all attendees will happen after the survey report form is filled out within 3 business days, and you'll be prompted to download a certificate of completion at the end of the survey. So I should also note that if anyone out there is interested in giving one of these seminars, please shoot me an email. So this whole slide presentation will be available, and you can get my email address there, but we're always looking for great presentations such as the one today. So thank you again to Greg, and thank you so much to Garrett at Open Architecture Collaborative, who has been behind the scenes here. And thank you so much to AIA Housing Knowledge Community and to EDI. So with that, we'll wrap up and hope everyone has a great rest of your day. And bye-bye.